In this video, I'll talk more about the Express framework. Specifically, we'll talk about how to scaffold a Express MVC application using the tool Express Generator. And we'll see a number of view engines and discuss what are the typical characteristics of a view engine and which ones you would probably prefer. And we'll talk about how to access a Mongodb database and then two related problems, how to put configuration parameters into environment variables, and how to do the so-called Greeceful Shutdown. And then we'll talk a little bit about authorization and authentication using JWT and very popular authentication framework for Node.js called Passport. So starting with Express Generator. Last time we saw how to create a web application using Express from scratch, but with this Express Generator we can have applications scaffolded for us, so it's easier to get started. The package name for Express Generator is called, Express Generator. You can install it as a global package. It will provide a command called Express, which you can use to create new Express projects. Or as I would typically like to use it, just use it using npx without installing it as a global package. So let's start by doing an npx express generator --help. It's a little bit slower than I expected. Okay, so here are the options of Express Generator. We just use the help option, which lists the other options. So most of these options are related to views. Express Framework supports many different view engines like EJS, Park, Handlebars, and so on. So I guess originally it supports a few of them, and then later on they added additional ones. So the current preferred option is to specify a view option and then pick the view engine you prefer. If you create a complete web API project without any view, you can use the no view option. And if you do a MVC project that uses CSS, you can specify CSS engines like less or sass. And if you want a git ignore file, you use the --git option. And after you specify all those options, you can specify a folder, and it will scaffold the new application in that folder. So most of these things are pretty clear. One thing I want to talk a little bit more is this view engine thing. View engine, I actually usually like to refer to them as template engines. They are things that combine templates with data to produce documents. In the web setting, they are usually used to produce web pages by combining HTML templates with data. The reason I prefer to call them template engines is because oftentimes it's not just for views. For example, if you have a web application that sends lots of email notifications, then you would want to put the email text into some template files instead of hard code your email text in your controllers, for example. And for that purpose, you would want to use a template engine to combine your email template text with some data to produce the actual email content. So these engines are not just used for views in MVC architectures. In other words, even if you just do a web API project, you may want to use a template engine. So in the class 3220, we use JSP. In fact, the way we use JSP is to use it as a template engine. This, for example, should be familiar to most of you. This one is a JSP page or a JSP fragment where we pass a user object to this JSP and then use something called expression language to access the first name property of the user. And then we use something called JSTL, JSP standard tag library, to do some basic control flow. For example, check if array or a list called task is empty. If it's not, then we use for each tag to iterate through each task in the list and then display each task. So this is something we did in CS3220, and this in fact is something universal for other template engines as well. In particular, if you consider a template engine, here are some common characteristics of all of them. Each template engine must have a template language that lets you to combine data with the text templates. And this language typically allows you to access objects and their properties, like this one. And typically they would also have some basic expressions, like this one, that let you to check, for example, if a collection is empty and produce a true-false result, and some basic control flow statements, like what JSTL provides us, a cif tag, which is basically an if statement, and the C for each tag, which is basically a loop statement. In addition to the template language, you would also consider some other characteristics of a template engine. For example, some template engines like JSP is server-side only, meaning that you can only use it on the server side, and application server will render this template. However, if you use Node.js or JavaScript, many JavaScript template engines can be used both on the server side and client side because, well, after all, they are in JavaScript, so they can actually render templates or render templates in a browser. And additional things you would want to consider is whether the template engine supports certain formatting options or internationalization options. For example, you'll specify a message, and then depending on the locale setting, it displays the message in different languages. And of course, performance is always a big thing you would consider if you want to choose a template engine. So knowing this, let's see very quickly the template engines supported by Express framework. The first one is called Hogan. This one is developed by Twitter, and it uses a very well-known template language called Mustache. The reason it's called Mustache is because the syntax uses these double braces, and they are like mustache, I guess, vertical mustache rather than horizontal. So this code is roughly equivalent to this JSP code, where you would pass a user object and use this double braces to access the user object and the first name property of the user. And then there's this very weird looking syntax, pound sign and slash, which let you to iterate through a collection of objects and so on. Personally, I'm not a big fan of Mustache because of its claim of being logicless. In my opinion, a template engine must have some logic. If it doesn't have any logic, it means you cannot do something like this in your template or in your view, means that you have to do extra work in the controller, and that makes the template engine a lot less useful. And in the case of Mustache, it's really not logicless. For example, this one obviously is a loop logic, so claiming it's logicless is kind of misleading, and in my opinion, not really making it any better to use. So to me, I would not choose Hogan just based on my distaste about the logicless claim, and based on my preference of this, or not preference of the logic. I prefer something that looks more clear regarding the display logic used. Anyway, handlebars is in fact an extension to Mustache, and in my opinion, making it easier to use by adding some explicit logic. For example, this is pretty much the same code as this, but you can see that by having each and if here, it actually makes the code easier to read, in my opinion. So I personally actually like handlebars, at least more than Hogan or Mustache. And then there's something called Dust, which is developed by LinkedIn, and you can kind of see the influence of the template language from Mustache. So even though it's not quite the double mustache, but it's still using the single mustache, and very similar syntax, the pound sign, slash, and so on. So yeah, it's basically another variation of mustache. And then you have EJS, which combines basically JavaScript code with HTML template. If you are familiar with the so-called JSP scripting elements, like JSP declaration, JSP expression, and JSP scriptlet, you can see that the syntax is pretty much the same. I'm fairly certain that EJS syntax is inspired by JSP scripting elements. The difference is that JSP scripting elements is for Java, so the code would all be Java code, and it will be only on server side. EJS, on the other hand, is using JavaScript code, and because it's JavaScript, it can render templates both on server side and client side. Again, personally, not a big fan of the JSP scripting elements type of syntax. It looks kind of messy and hard to read, but one positive about EJS is that it's generally considered one of the best performing template engines, much faster than many others. And then there's Twig, which was originally a PHP template engine. Again, the syntax is a little bit mustachy, not quite, but yeah, that's all I can say. And then there's Vash. Vash is actually using Razor syntax. If you like the Razor template engine used in ASP.NET and ASP.NET Core, you may prefer using Vash. And although I'm a big fan of ASP.NET Core, but once I move away from that, I actually would prefer something different, not Razor in a different environment. But yeah, if you prefer Razor syntax, this one would be for you. And then something looked quite different from all the others. If you look at the others, many of them are similar to Mustache, and then there are a couple of them that tries to essentially combine code with HTML, and this one combine uses Razor syntax. This one uses essentially JSP syntax. Jade/Pug are quite different from the others in the sense that, as you can see, it doesn't have the HTML tags. Jade and Pug are essentially the same thing. The earlier versions were called Jade. I think there was some trademark problem, so the later versions changed the name to Pug. Either way, if you look at the syntax, it's quite different in the sense that the other ones all have plain HTML template text. This one actually give you a different template text without all the tags. So if you want a HTML paragraph, you'll just say P and then whatever in the paragraph. And when the template is rendered, it will automatically render the full tag. So some people actually like this a lot because the syntax looks more concise. Me personally, not quite, although this type of syntax is more verbose. Mentally, I can easily see the HTML tags and recognize the HTML, but this one I have to do some mental conversion from this into HTML, and that doesn't make this better to me, at least. So all these are template engines supported by the Express framework, and you can choose one of them based on your preference. As you can see, many of these are developed by major companies like Twitter, LinkedIn, and so on. So you know that they are good enough for pretty much all your needs. It mainly comes down to which syntax you prefer, whether you prefer something looks like JSP or something looks like C# code or whatever, or something like this. Me personally, if I have to choose one, I will pick handlebars because I prefer this type of syntax more. Okay, so once you pick a view engine, then we can start scaffolding the application using Express generator. So let's do that. We'll do this, and we'll say the view engine we'll use will be HBS, handlebars. HJS, by the way, is Hogan, so they look very similar, but they are different. So I'll use handlebars, and then I'll also want git ignore file, and what else do we need? No, nothing else. And I want you to put it into a folder called Express Examples. Okay, I forgot the S, but that's okay. All right, so now we have a new folder, and this folder will have the skeleton of Express web application. Okay, so this is what the folder looks like, and first thing we probably want to look at is the package.json, and two things here. One is the packages is included for us. We see Express here, we see handlebars here, and a few others like cookie parser and so on. One thing to note is that it's using the tilde syntax, meaning that it will automatically update to the latest patch version, which is kind of too conservative, especially these days with all the security patch and so on. So I'm going to change all that to update to minor versions instead. And another thing to note is that it creates a package.json for you, but it doesn't do npm install. So we'll need to do npm install ourselves to get all the packages. So we'll do that. Okay, so we have installed all the packages, and as usual, I would also want to install nodemon so that we can automatically restart during development. I'll do install nodemon and then save dev. Okay, so now here it is, and let's first run it, make sure it runs, and then we'll look at the code. I'll do npx and then nodemon and then bin www. We'll see what that thing is in a moment. And if we go to localhost 3000, yeah, we'll see Express. Welcome to Express. So it's working. And knowing that it's working, let's look at some details. First is the package.json. We already saw the packages. Another thing to pay attention to is in the scripts, there's a npm start script which says node bin/www. Basically means that if you want to run this project, you would want to run this file called www under the bin folder, which is this file. And this is basically the startup script for the project. We'll take a closer look at it in a moment. And then there are some folders. There's a folder called public. This is where you can put the static resources like images, CSS files, and so on, which is this one. There's already some subfolders in them. And then there's a folder called routes, and this is where you would want to put your controllers. As we talked about last time, controllers in Express frameworks are called routers, and you can have a index router, you can have a users router that handles users and stuff. And automatically generating code doesn't really do anything other than putting in the route, other than putting in a couple of routers. And views, of course, is for the view templates, and this is where we find our various mustache stuff and handlebar stuff. And so here it says welcome to title. Well, we'll talk about that in a moment. And then there's the bin folder, and this is where you'll put executables like the www script, where you can start the project and you can put additional script that you will run inside this folder. So if we look at this www script, we can see that it really doesn't do a whole lot. So it will load the app, which is this file which is much more important, and oftentimes you'll need to put additional code in here. But www is something that you probably don't need to change most of the time. And what it does is it will check whether there's an environment variable called port. Oops, let's not change that. And here there's an important object called process. Notice that process is not declared anywhere. That's because process is a global object in Node.js. And this object lets us to get information about the process that runs this program, and also give us a number of ways to control this process. For example, if we want to terminate the process, we can say process.exit. Now, here, what this one does is it's using the process object to access the environment variables, and it will check if there's a environment variable called port, and if there's a environment variable called port, it will take that value. Otherwise, it will take 3000, and that's why here the port is 3000. And then it will create the server, and it will run it, and there's some error checking, and this and that. But all in all, this file doesn't do a whole lot. It basically gets a port number from an environment variable. If not, defaults to 3000, and then it starts the server. So, as I said, most of the time you can just leave this file be. Now, this app.js is an important file, and oftentimes you need to change code in here. So we actually saw this one last time. This is basically the place where we add a bunch of middleware to the application of Express. We've seen middleware like Json parser and URL encoded form parser and so on. And here it included a few other packages, like a cookie parser, which will pass cookies and so on. And it imports two routers, and then mount the index router at the URL slash, and mount the users router at /users. So this is why we have this one, and if we go to users, we see respond with a resource, which is what is sent here. Important thing in this app code is it says the view engines. So it does two things. First is it says the place where the views can be found, and notice that it says views, and that's because we will be putting views under the views folder. If you change this folder name, you can simply change this one to match. And then it says the view engine, which is handlebars. And what else? Oh, there's a fairly important middleware called express.static. This middleware is responsible for sending back the static resources. Remember, in Node.js, a web application is its own server, so there's no application server that's responsible for sending back static resources like images, icons, CSS, and so on. So you have to do it yourself inside your application. And Express provides a middleware called static, which handles sending back static resources. All you need to do is tell where static resources are, the folder name. So it says public, which It's because this folder is where we put static resources. And then any request comes in that matches any of the files under public, it will be sent back by the middleware, by the static middleware. And then if the request doesn't match any static file, it will be handled by the routers. Very importantly, remember middleware order are important. The request will go through the middleware pipeline, and if it's handled by one of the middleware, it will not reach, well, in some cases, if it's handled by one of them, it will not reach the other ones. And then Express generator creates a couple of additional handlers. This one handles 404, and in fact what it does is if a request doesn't match any handler, it will reach this handler and it will create an error 404, and that error will be handled by an error handler, and that error handler will render the error view, which is this view. Okay, so that's kind of the basic structure of the scaffolded web application. If you use, if you have an MVC application, it will have views and so on. And if you do a web API, just use the no view option, and it will still have all the routers and stuff, but it won't have views. Now, knowing that, let's look at a controller, and here, let's look at the index controller. So what this one does, well, this one is basically this one. So there are a few important things. First is, notice that the handler function takes 3 arguments, request, response, and next. And in our previous examples, in the last video, we typically just use 2 parameters, request and response. That's because we kind of assume that no error will ever occur. But if it's possible to have an error, then you would want to use a 3-parameter handler function, and you can call next error if there's an error, and that will pass the error to the error handler instead of handling it with a regular middleware. And the second important thing is here. If you look at the API of response in Express, you'll see a render method, and this render method is the method used to render views. And just like in Spring Framework, you need to pass a view name to it, and that view name, of course, will result to a view under the view folder and convert it into a path with the suffix HPS, because that's a view engine we use, right? So that basically will be mapped to this handlebar file, index.hps. And just like in Spring, we often need to pass some data to the view in order for the view to render. In Spring, those data are called model attributes, and we do something like model map and add an object and so on. In Express Framework, it's called response.locals. So response.locals is basically an object we attach to a response, and this object can then be later on used by the view. So here we passed an object with a property title with the name Express, and that's why we see welcome to Express here. And if I change this to CS5220, for example, and it will say CS50 to 20 because we are passing this object to this view, which will display CS50 to 20 here and CS50 to 20 here again. So all in all, as you can see, all MVC frameworks are not that different from each other. You still need to have a template engine or view engine. You still need to have a view name, result to a view file, and you still need to have a way to pass data to the view as an object. And here, the object is called response.locals. So this is the controller part, and then the handlebar views. If you look at this handlebar view, you can see that it's not a complete HTML file, it's only part of an HTML file. The reason is that handlebar supports layout files. So you can have a layout file, and this file can have the common headers and footers of your website, and for most pages, all you need to do is put different body inside. And by default, the layout file is called layout.hbs in handlebars, and if you want to use a different layout file, you can set a layout local to use a different layout file. For example, you can say something like layout and then another layout file like layout 2 or something, and this would allow you to use a different layout file. And to render a view, Express basically combines a layout file with the content of the content page. And notice that most of the time you see double braces, but for layout you see triple braces. The difference is that triple braces means do not escape content, so it will preserve the actual text. Otherwise, the text will be considered special characters and then rendered differently. Okay, so for our purpose, we are really not going to use handlebar for anything serious, since we'll be structuring our applications using the backend REST API plus front-end single-page application structure. But if you ever need to create an MVC application using Express, this is how you can do it. And now that we have the basic controller model and the view, let's see how we can add MongoDB to the mix. And first of all, let me find my MongoDB code so that I can copy and paste. Where is my MongoDB code? Here. Okay. So we're doing Node.js, and which one do I need? Callback. Yes, okay, let's do a callback. So so this is what we saw when we talk about MongoDB, and to connect to a MongoDB server, you would say something like Mongo client connect, and then it will return a client, which you can then use to connect to a database, and then later on select a collection inside the database, and then later on run some queries or other statements in the collection. So this is how we can connect to a MongoDB database. Now, the very first important thing to understand is that MongoDB client actually maintains a connection pool, meaning that this thing that you get is actually a connection pool, not just a connection. So if you look at the API, you can actually see that there's a pool size option when you try to connect, and by default it's 5, meaning that by default it will create a connection pool with maximum 5 connections, and you can adjust this number based on how busy your website is and so on. So what this means is that it's very important that you reuse the MongoDB client that you get from the connection call. So you want to reuse this as much as possible, because if you close it and then reopen it, it's quite expensive, and you definitely do not want to do it per request. That will be very, very, very inefficient. So the typical, the commonly recommended way is to create a MongoDB client and then save it in this property in Express called application.locals. It's a property in the application object called locals. So this is pretty much like the application scope in Java EE, basically where you can keep something for the duration of the whole application or the whole server lifetime. And when you shut down the server, of course, this will be gone, and that's when you want to close down the client. So knowing that, let's see how we can do this. The first thing is, of course, we want to install MongoDB first. Let me close this one, and we'll say install MongoDB. And then we'll import Mongo client, and we'll do it somewhere here. Where do I do it? Let's do it here. And then we want to make the connection. So let me get this code. Where do I want to make the connection? We have to make the connection after we create the app object, because later on we want to save the client into app.locals. So let's do it here then. So we'll have my username and password and then DB URL. So I got a few questions about localhost, which means it's probably better to make this configurable parameter as well. So DB host would be this, and DB port would be 42, and let's do DB port. Okay, so this is the URL, and we want to make a connection, and so here, here, if there's any error, that means somehow we couldn't make a connection. In that case, we'll say console error, fail to connect to database, And if we cannot connect to the database, there's no need to do anything at all. So we'll say process exit. Remember the process object that we saw earlier in here, and the process object has a method called exit, which basically lets us to exit the whole program. You may be wondering what's the number 1 means. This is, I think, a Unix / Linux thing. So when a process exits, it returns an exit code that other process can use to determine whether the process exits normally or exit because of some error. The convention is to say 0 means it exits normally, or non-zero means it exits with certain error. And then, depending on the process, you can specify different, you can use different values to represent different errors. In our case, we don't really care too much, but we would want to use a non-zero value to indicate that this program exits abnormally because of failing to connect to database. But if we can connect to the database, then we'll say console.log connected to database. And then we would want to save this client in app locals. So we'll say app.locals. We need to give it a name, property name. I'm going to call it Mongo because later on I also want to save a DB in there. So I'm going to call it Mongo here. And notice that here, once you get a client, you can get a database to use. And here we will only use one database called CS50-20STO31. So since we only use that one database, might as well put it in app locals as well. So I'll say app locals db is client.db, and then the database name is the same as the db username. Okay, so this is pretty much it. I think. Do I need the rest of it? No. So okay, so let's get rid of the rest of the code, and so this should let us to connect to the database. Yeah. Okay. So suppose we connect to the database, and then later on we can use it, and then let's actually use it here. Use it in users. Let me open up Compass. Takes another half a minute to start. Okay, so let's connect to my database, and I do have a collection called users. There are some users in there. Doesn't really matter who they are. So let's say I want to send back those users in a JSON object, not display in a view, because we don't care about views. So what we would do here is we need to get the database from here. So we'll say this is the database. And in order to run queries on the users collection, we'll have to get the collection. And here, notice that in order to get a collection, not a connection, a collection, in order to get a collection, this db.collection is an asynchronous function, meaning that we either need to give it a callback or we need to handle it as a promise. So here I'm going to handle it as a promise. So I'll say let users be app.locals app.locals.db.collection users. Now, because this call is an asynchronous call, I have to do a await. Now, because I'm doing a await here, I have to make this an asynchronous function. By the way, Express does support having asynchronous functions as middleware / request handlers. So that's a very nice feature. It allows us to use await inside this this code. Okay, so oh sorry, missed one thing. So we cannot just use app.locals here because there's no app. As you can see, there's no app variables declared anywhere. The way to access app in a request handler is to say request.app. So app is actually a property of request, which allows us to access all the app properties like locals and so on. So it looks like something like this. So this one will be a MongoDB collection, and then we can run all kinds of different queries on the collection. Here we can just say users find and to array. So this should give us all the users as an array, and we can just send everything back as Json, and let's put it here. And yeah, so the code looks like this. And let's try it and see if it works. So it says connected to the database. That's a good sign. And if we go to users, it returns empty. Oh, users find is another asynchronous function, so we need to wait on that as well. Otherwise, it will give us empty. So now we get the 4 users in my Mongo collection, and so our database part works. Now, although it works, there are a couple of things we can improve upon. The first is this part. It's very common that we have configuration parameters like database username, password, host port, and so on and so forth. And we certainly do not want to hardcode them inside the program because it makes the program very not portable. So different developers working on the same program may have their own database and their passwords and so on. So we certainly do not want to have this type of information in our program. So where should we put them? If we write Java applications like Spring Boot, and typically Java applications use property files that we can put this type of information outside the program. For Node.js applications, they typically use environment variables, like what we saw in here, getting the information from the environment variable. But of course, if you have to set environment variables manually, and especially if you have to set several of them, it's quite tedious. So this is why there's a very popular package called .env, This one lets you to set all your parameters inside a file called .env, and then when you run your program, you can simply run the package.config, and it will automatically set all the environment variables based on what you have in your .env file, and then later on your code can then use them. So in other words, we can install that package. We'll say npm install.env, and then we can create a .env file and put everything we want in it, all the parameters we want in it. So we'll say port will be 3000, and the DB host will be say 3.LA, and the DB port will be 4042, DB username would be 2071, DB password would be ABCD. So this will be our .env file, and inside here we can then do something similar to what this part of the code does. We'll say, for example, DB host will be, oops, not here, will be DB host, or if it doesn't have that environment variable, we default to localhost, and DB port, if we have a DB port, we'll use it. If we don't, we'll default to 27017, and if we have DB username, we'll use that, otherwise we'll default to Json, and if we have DB password, we'll use it, otherwise we'll default to ABCD, something like that. If I run this code again, forgot the important thing. So we have to run this as the beginning of the application in order for .env to set all those environment variables based on this. Now, technically, the beginning of the application is in here, but notice that the very first thing www does is to load app.js, which is this one. So once again, we don't really need to change here. Instead, we can put require.env config here. So if I run this code again, and if it works, it means these are set properly. Otherwise, we'll end up using localhost, which will give us an error. So let's see if I run this again. It says connected, so that's a good sign. And if I refresh, so still works. Okay, so now .env works. Now, .env typically will contain lots of sensitive information like your username, password, and so on. So obviously, you do not want to version control this file because otherwise, many people will know your password. So if you look at the .git ignore file, you can actually see that this one is in the .git ignore file, meaning that Git will ignore it. But you do want to version control something so other developers know which environment variables they need to set. So my recommendation is that how do we make a copy of this? Paste. You make a copy of it and you call it .env.sample or something. So you would want to version control this file, but with some placeholder values there so that people know which environment variables they should set without exposing your own sensitive information. So this is how we can configure different startup parameters, let's call them. And then there's one more thing. Typically, when you use a database, you would want to close your connections when you no longer need them. And in this case, is when we exit the program. And that's actually an important thing known as Greeceful Shutdown in Node.js. That means when you shut down, you should properly save your data, release resources held by the application like database connections and so on and so forth. Now, in Java, we really never need to worry about this before because we have an application server, and application server handles Greeceful Shutdown, and it has a number of hooks that you can hook into if you need to do certain things before application server shuts down and so on. But in Node.js, the application is the application server, so there's no other thing you can rely on. You have to handle Greeceful Shutdown yourself. If you look at Express documentation, there's actually a guide under advanced topics about adding health checks and Greeceful Shutdown to your web application, and the recommendation is basically use one of those packages. Here I want to roll our own Greeceful Shutdown solution because I want to talk a little bit about the things involved in Greeceful Shutdown. So we already saw the process object. This is an object in Node.js that lets us to know the information about the process that runs the program, and it also gives us some control over the process. For example, we can call process.exit to terminate the process. Now, if you think about it, we'll think about Greeceful Shutdown. The first thing you probably would want to do is look up the API documentation and see if there are any events related to shutdown, and then we can put our shutdown code inside the event handler, and that will be it. It is unfortunately not quite as that simple. You would see a couple of events that look promising. For example, something called before exit event and exit event. But unfortunately, this is not something that we can use. They are related to normal exit, like when the program just runs its course and then end. And but in our case, when you terminate a web application, when you click, when you use, for example, Control-C, it's not a normal exit. So these exit events do not really help us. Instead, we need to handle something called signal events. So signals are used in IPC, which stands for inter-process communication. Now, in a computer, there could be many processes, and if you are not inside in a process, you cannot quite control that process directly. So There are the so-called inter-process communication. Basically, one process can send signals to another process, basically saying you probably should exit or terminate or something. So signals are basically things that one process can send to another process. Now, even with signal events, things are still a bit complicated. The reason is there are many ways to terminate a process. For example, we can click Ctrl+C to terminate a process, and in this case, for some reason, Ctrl+C doesn't even work. Keep clicking Ctrl+C. Sometimes Ctrl+Z or Ctrl+D would work, but in this case, Ctrl+C or Ctrl+D doesn't work either. And now sometimes, if I really want to just terminate it, I can close the window, right? Or I can shut down the computer. So there are all kinds of different ways to terminate a process. And let me go back to that folder, and let me make sure it is indeed terminated. Yes, so it's terminated. No, I don't have COVID-19, in case you are wondering. Okay, where I am at. Yeah, so process termination is complicated. Many ways to do it, and some termination events do not even accept event handlers. For example, if you close a window and that event will simply terminate the process started inside this window, and there's nothing you can do about it. And then different platforms work differently. If you use Linux, if you use Windows, or if you use Mac, certain things work differently. And on top of all that, there's process managers like nodemon, which is one process that controls another process, and when you click Ctrl+C, which one you're really, trying to terminate, and so on. So all in all, it's a pretty complicated situation. That being said, typically if you want to do graceful shutdown, you would want to handle these three signal events. The first one is sigint. Int stands for interrupt. So it's you're interrupting. Well, it's a signal representing interacting a process, and this is the signal a process will receive when you click Ctrl+C, and this is also the signal a process will receive if you use the PM2 package to run the application as a background process. So this is a very important one to handle. And then another signal you also want to handle is sig_term. Term stands for terminate or termination, I think. And this is used by some cloud services like Heroku to terminate certain processes, and so you need to handle this one as well. And there's yet another one you want to handle. It's called sig_user2. This is a user-defined signal that's used by nodemon to restart a process. So having said all that, this is kind of the code that we would want to write. We would say process on. Remember on, we talked about event handling in Node.js. Process is a so-called event emitter, and you can add event handlers using the on method. And this one basically says if there's a int event, run the shutdown function. And this shutdown function basically says, let's close the database client, and it will close down all the connections in its connection pool. And then after that, we can do two things. If there's a callback function, we'll call the callback function. If there's no callback function, we'll simply exit the program. And this one will use exit 0, meaning it will be considered a normal exit. So for both sigint and sigterm, we'll run this shutdown function. But for SigUser2, it's a little bit different. Instead of just run this shutdown, we will run part of it, and then we will, instead of exit, we will resend this signal again to the current process. This is because it's the SigUser2 is sent by node1, and the node1 does its own thing. So we want to shut down the we want to close the database client, but we also want to continue to let node1 to do whatever it does. So we run our database collection, close code, and then we resend the same signal to the process. By the way, the kill method simply sends a signal. It doesn't really kill the process. It's for historic reasons. It's a method to send a signal rather than actually killing the process. Okay, so this is the code, and where do we put it? Excuse me. And we'll put it here, I guess. And okay, so here let's add a little bit logging to see where how things go. We'll say disconnected from database. Yeah. Okay, so let's run this. We'll do npx node1. So it says connected to database, and if we restart node1, so there's something wrong here. Let me try again. I think there's something wrong here. We sending SigUser2. Let me try again. This time let's use node first. Node kind of makes things. So I do Control C. Okay, so this part of the code works fine. So Control C, it will disconnect from the database and then exit. So that works fine. And if we do node1, and if I press Control C here, so somehow this one is not working correctly. I think this may be the part that's related to platform. Yeah, I think this part may not work properly on Windows. Not quite sure. So it has it calls this callback. Yeah, so when node1 restarts, it should send seek user 2. For whatever reason, it's not. Okay, I'm not quite sure about this. I'll test the code again and see if it's because of different platform or something. I'm not quite sure. Okay, but at least for the first two signals, it works. That's, I guess, good news. Okay, so moving on from here, and let's talk about security stuff. And we talked about using JWT to secure REST API when we talk about when we use Java to implement the API, and same thing can be done using Node.js, just with different packages, of course. The package we'll use is called Json Web Token, which is this one. And this one has a method called sign, which let us to create JWT tokens, basically. And this, of course, is when a user authenticates successfully and so on. So let's do that, and I'm going to do npm install JSON Web Token. JSON Web Token. And we'll use it to implement a logging endpoint, something like this. So we'll say router host, and we'll say login, and then we'll say request and response. Do we need next? Probably not. Okay, so we'll assume that the user will send in the username password in request body, and we can, of course, check get the user information from database and do all that. But as an example, I'll just do something simple. We'll get the username from request body, and we'll get the password from request body. And we'll simply check if username is Json and password is ABCD. If that is the case, we'll send back a response. Okay, we need to generate the token first. So we'll generate a token, and that requires us to use JSON Web Token. And so we'll get this patch. And this is how we can generate a token. So we put it here, and then we'll use this to generate a token. So the first part of the token is whatever you want to put inside the token, and that's usually a user object with user information that you want to use later on for authentication purposes. And so that means, let's say we'll put username in there, and we'll also say this user is not an admin user, and this is some information that later on you may use to do some authorization. And the second argument is the secret used to encrypt the JWT token. And once again, you would want to put that inside your .env file, and let's just say secret is called hello, and put it in the sample as well. And here we'll say secret is process environment JWT secret or ABC or hello, something like that. And this one will use secret to encrypt it. And then once we get the token, we'll send it back inside the response. We'll say Json, and then the token will be token. Okay. Now this is when the username password happen to match CYSON and ABCD. If it doesn't, then we'll send back status 401, and we'll send back this object says something like authentication failed. Okay, so this would be our logging endpoint. Let's write. Authentication failed. And let's write. And let's open up Postman. And we want to send a request to users logging using post, and the body will be a form, and the username will be, wait, what did I do here? Request body username, okay. Username, let's say Json, and pass. And the path, why it doesn't let me to add more content type? No. Let me create a new request. HTTP localhost 3000 full service login, and username Json, and path. Why? What's going on? Why when I click this one, it goes up to the other one? Username Json. Oh, what's wrong with my Postman? Localhost users log in. Why? I don't understand why it only let me to send one parameter. In any case, let me send a parameter. So it says authentication failed, which is the correct response, and oh, finally. Okay, so great. So now we have a token, and if we check, so this is indeed a valid token, and the payload is username and is admin, and it says invalid signature, but if I put hello here, it will say signature verified because hello is our secret. So this is indeed a good JWT token. So now once we have a good JWT token, of course, we can then use it to protect our API, and in certain endpoints will require JWT token, and then once we get the token, we can extract the user information from the token and then decide whether the user can have access to that endpoint or not. So that's the authorization part. Now, if you have to write JWT authorization yourself, it's not too difficult to do. You just need to extract the token from the authorization header, you verify signature. If the signature doesn't verify, you send back a 403 access denied. And if it does verify, you attach the payload to the request and pass it on to the next middleware / request handler. And you can do that yourself, but we want to use a library, of course. And there's a very popular library called Passport. And this library is essentially an authentication framework. Framework in the sense that it gives you a few hooks, and then you can add a bunch of so-called strategies to it. If you use JWT, you can add a JWT strategy. If you use Google authentication, you can add a Google authentication strategy to it, and so on. So as you can see here, it claims to have over 500 strategies already implemented. For us, we are going to use JWT, of course, and that requires another package called Passport JWT. So let me install those two packages. So install Passport. And we'll install Passport JWT. And then we'll write some code. So that code is something I'll just copy and paste because I don't write that code often and cannot remember it. So I'll just copy and paste the code from here. Okay, so this basically is how we can use passport JWT. So what this one does is it registers a JWT strategy with passport, and to make this strategy work, we have to give it the secret so that it can use it to verify signatures. And we also need to tell it how to extract the token. Here we are going to extract the token from the authorization header as a bearer token. In the passport JWT package, you can find some additional extraction strategies. You can, for example, extract the token from a cookie instead of a header and so on. And what this one does is it will automatically decode and verify the token for you and send back an error if the token signature doesn't verify. If it does pass verification, it will pass the decoded payload and the down function to the callback function. So what it will do is it will pass the decoded payload and another function called down to this callback function. So you may be wondering why you need a callback function after it's already verified the signature and decoded the payload. The reason is that sometimes you may want to do some additional processing of the payload of the JWT token. For example, loading a full user object from database. So that's why this package allows you to do that by adding your own callback function and own additional processing to it. Now here I'm not really doing any additional processing, so I simply call the down function here. The down function takes two arguments. The first one is an error object, and I pass a null to it, meaning that there's no error. And the second one is what you want to set as request.user. So what this one does is it will set the second argument as a property called user to the request object, and then the subsequent middleware can then access the information of the information extracted from the token as request.user. So here again, I'm not doing anything extra. I just set the payload to request.user, and the payload is essentially just this object. This object, username and is admin. So the way we can use passport is again it's a middleware in Express. So the first thing we do is, well, we need to require it first. So inside application, we'll say passport require auth. So notice that auth export object called passport, and then we want to register passport initialize as a middleware. So we'll do that. And typically you want to do it after you register the static middleware, meaning that all the static resources do not have to pass authentication, but you may want to put a restriction on your API endpoints. So we'll put it here. Now, how do we put endpoints? How do we restrict access to endpoints? Well, we add passport as a middleware, of course. So here, for example, here, right now, everybody can access that everybody can access that endpoint to see all the users. Is it running? No, it's not running. Right now, everybody can access, but we could add another middleware here. Basically, said this. So we basically add an additional middleware in front of the request handler. So this middleware will check JWT authentication, and if it passes JWT authentication, it will get into this part. So here, for example, if we, now this is a problem of not using NodeMon. I have to manually okay. Cannot find the module auth. Oh, okay, that's because it's in the parent folder. Okay, so now if we try this again, it will give us an unauthorized error because we don't have the token. So to add the token, let's try it here. We'll go to users, and we'll need to do authentication, and we'll need to add a bearer token, and the bearer token is this one. And if we send that request again, this time it gives us all the users again. So this is how we can secure a single endpoint, basically attach this middleware in front of the request handler. And here we can also do request.user, and so it prints out the current user information, and so if you want, you can use whatever in request.user to decide whether the user can access certain things or not. For example, you may check whether the user is an admin or not to decide whether the user can see all the users or not. So this is how we can use Passport to secure endpoints. And the example here secure only one endpoint, but you can use it to secure a bunch of endpoints that starts at a certain URL by registering this as a middleware at the application level. So you don't have to do this for individual. You don't have to do this for individual endpoints. Okay, so that is it for this video. We have covered database access, some security, and a few other things. And I'll find out why the seek user tool event didn't work, and post some additional information in this weekly discussion. Okay, so this is it for this video. See you in the next one.